are responsible for knowing how to use them. I will put these on the test paper itself, so they will be right there. And of course, as you do your homework, you will just use them out of the book. All right, but let's look. What was the first one? Was it 49?
Yeah.
Okay. Jolinda contributes to the retirement fund that earns 12.4% annual interest. What should her monthly payments be if she wants to accumulate $250,000 in 20 years? Now, if you are making payments of any kind, whether it's car payments, house payments, payments into your retirement fund, if you are making payments of any kind, you are going to be using one of these formulas in the book, okay? This is not the formula that was on your quiz. That's compound interest. This is not the PERT formula. That's continuous growth. These are payment formulas, and there are two of them. In one of the payment formulas, you are investing for the future. It's called future value. In the other payment formula, you are making payments on something that you owe. That's called present value. So when I read this problem, it talks about making contributions to my retirement fund for a future value. So I'm going to find my future value formula. And it looks like this. They are very messy. Isn't this clean board awesome?
Yeah.
All right, now we need to talk about what all these letters mean. Okay? So here we go. Back to my problem. What should her monthly payments be? This is the payment amount right here. So that actually is going to be my variable in this problem. We want to accumulate $250 or $250,000. So that's over here. That's my future value. That's what I want to accumulate. Now here's where things get a little bit different in this formula. You will probably guess that I is the what? Well, not in this problem. It's not. I is the imaginary unit, but not in this problem. That's on video unit. What do you think I is? The interest rate, right? Now here's what's tricky about it. It's the interest rate per month. It's the interest rate divided up into these monthly pieces. So when you put this into your formula, you have to put in 0.124, that's the interest rate, divided by 12. That's what goes in for I. And then N is the total number of payments that she's making in the whole problem. So N is the total number of payments. So think about this for a minute. How many payments a year is she making? 12. For how many years? 20. So N is 240. You do not, in these formulas, you do not put in the actual interest rate. You have to divide it up, how much interest per payment. There are 12 payments, so 0.124, that's 12% interest divided by 12. N is the total number of payments in the whole problem. So she's making them monthly for 20 years, that's what N is. Now, what do you think I'm going to put down here? It's the same thing, kids. When you have a formula and the letter occurs twice or 3 times or whatever, it's the same thing in the whole formula. So the denominator is 0.124 divided by 12. This is the setup for problem number 49. Now, we need to type that in on our calculator, and this is where it gets interesting, but we can do it if we just do it logically a step at a time. Am I going to need logarithms to do this problem? No. Basically, it's a division problem, isn't it? I'm going to take 25 or 250,000 and divide it by this bracket. Would you agree? So let's just figure out what that value of that bracket is. So let's do this parentheses first. So I'm just going to do 1 plus 0.124 divided by 12. Okay, so I've got my parentheses. I'm not going to write it down. There's no need to write it down. It's on my calculator. What do I want to do with that parentheses? Raise it. So I hit equals, and then I'm going to raise it to the 240th power. You should have about 11 point something. So now you got this. Now what do you need to do with that? Subtract 1, hit equals. So now you have 10 point something. Now we're going to divide by this, right? So when you hit divided by, put parentheses, because you need to divide by that fraction. So we're going to divide by parentheses 0.124 divided by 12. Did you get 1,044?
Yeah.
Okay. Now, the value of this whole bracket is 1,044. So what are we going to do to solve for R? Take 250,000 divided by answer. And the amount of her payment is about $239.41 per month. Now let's try 51, because 51 is a different scenario. 51 still involves payments. Agreed? Making payments. So we are not using one of our memorized formulas. If you are making payments, you're going to, of any kind, I don't care what you're paying off or what you're paying into, if you're making payments, you're using one of the formulas in the book. Okay? But what's the difference this time? That problem, what was she doing? Accumulating for a future value. She was like saving money there, right? What's she doing in this problem? She's paying off the present value of a loan. So this problem is going to use the present value formula, which I can get out of my book, because I don't have it memorized because it's a mess. And everything stands for the same as it did in this formula. So, what is Kim's monthly payment? This is her payment right here. This is always the payment. So that's what I'm actually solving for once again. I will do some problems where you're solving for something else. But that's what we're solving for again. Do you see that? What is the present value of the loan? PV, present value. What's the present value of the loan? I'm on number 51, aren't I? Am I doing the wrong problem? $9,000. And I've got 1 minus 1 plus. Okay, now what do you think I is in this problem? 0.0795 divided by 12. Isn't she making monthly payments again? So 0.0795 divided by 12. And that's going to be the same as the one in the bottom. Now, what's my N this time? Remember, N is always the total number of payments. How many payments is she making? How many? 48. So we're going to put a negative 48 on this. Remember, in both of these formulas, when you put in your interest rate, you have to divide it by the number of payments per year that you are making. Almost all of these will be monthly, so you'll almost always be dividing by 12. When you pay off your house, you make monthly payments. When you pay off your car, it's monthly payments. Your credit card is monthly payments. Okay, got it? All right, let's see if we can type this in. If you want to type in the whole numerator, you can do this. You don't have to do this in steps. You can type in the whole numerator as long as you are sure to put these parentheses in. So if you are comfortable typing in the whole thing, you would type 1 minus parentheses, 1 plus 0.0795 divided by 12, close the parentheses, and raise to the negative 48. Now you could also do that in steps. You could do the parentheses, raise it to the negative 48, and then 1 minus that answer. What did you get for your numerator? Somebody else want to touch base? 0.27? Now, we need to divide by our denominator, right? Once you get the whole numerator in, you gotta get the whole numerator hit equals. Now we're gonna divide by the denominator. Make sure you have that in parentheses. So this bracket turns out to be about 41. Now what do we need to do to get the answer to the question, which is right here? We have to take 9,000, oops, and divide it by that. So what's our car payment? About what? $219.51? Okay, how do we know what will be happening in the problem if we're going to be using one of these two formulas? Payments. Any kind of payments. If it talks about payments, you're going to be using these two formulas. Because the ones that we used before, the ones you have memorized, those do not involve putting in more money. You go down to the bank, hand them $100, and come back 5 years later. That's what happens with those formulas. Here, you keep putting more money in. You keep making payments. These formulas are used for that. How do we know when we use FV versus PV? If you're investing for the future, if you're trying to accumulate a future amount, like you're investing for your retirement, you're going to use this one. If you already know how much you owe and you're trying to pay off the loan, this is the formula you use. Car payment, house payment, credit card payment. Okay? All right, let's try one more of those. I want to find one that doesn't ask for a monthly payment. Oh, how about 47? What do you think about number 47? Which formula will number 47 be? PV or FV? Everybody, FV, because we're saving for the future. So we're going to use this formula. All right, what's going to go where? What's my variable? What am I solving for? I'm solving for this, right? How much is my payment? $50. What's my interest rate? 0.0726. Well, what do I need to do with that?
Divide by 12.
Divide by 12, so 0.0726 divided by 12. What power am I going to raise that to? Whatever 25 times 12 is that 300?
Yeah.
And I'll divide it by this. So everybody, please look at problem 47. Please look at what I wrote on the board and make sure you understand where all those numbers came from. Because now you have to put it into your calculator and get the answer. Now I'll let you do this on your own. Do it however it makes sense to you. Here's what I got. These are a little tricky though, make sure. Am I right? $2,000 off. Okay, that can't be right then. Something's wrong. Someone's wrong. Let's see.
I got what you got.
Yeah, me too.
It's a scary thought, Harry.
Oh, I see.
Yeah, I got the same thing
I
again.
put in a 1 instead of a 2 for 0.0726.
Oh,
You
okay.
got 0.
Wow, that's interesting, isn't it, Delaney? She used an interest rate, this interest is 4.26%. She used an interest rate of 4.16%, just accidentally, and it caused a $2,000 difference. It's pretty interesting, isn't it? All right, we good on that? Okay, tonight you'll have a chance to practice some more. Were there, those like 4 of you that did the homework last night, were there any questions about the other ones? The 1 through 11 ones? Madeline?
Can you do 4 or 3 or 7 or 5 or 7? I didn't get like the K times.
5 or 7? Okay, so 5. 5 says find the amount after invested a principal for 2 years at an interest rate compounded K times per year. So that's going to be your compound interest formula. And they're telling us in the problem that in number 5, for example, that we are investing $1,500, that our interest rate is 7%, that we're leaving it in there for 5 years, and we are compounding it 4 times per year. They just give me all that information. Now, do I need logarithms to solve that? That's just a straight plug-in problem. I'll just plug all that in. So if I plugged right, it's about $2,122 if I plugged it in right. Okay? All right, let's look at the sheet we were looking at yesterday, which was the one where your quiz came from, basically, the extra practice 12208 paper. Down at the bottom, there are some challenge problems. These are not really challenge problems. These are GTQs. So let's see if we can figure out how to do these. We've actually done some of these before. Yeah,
Can I go to the bathroom, please?
sure.
Thank you.
Okay. We have done some exactly like this before. You may or may not remember it. This is some random made-up given. Okay, we are at the bottom of the sheet that we did yesterday. We did the first 10 problems yesterday. Down at the bottom, there are some challenge problems. We need to do those now. Okay, this is the extra practice 12208 sheet that we worked on yesterday. Now, this is the given, and based on the given, you are to find the log of 10. Now, I want you to think about this for a second. They gave you 2 and 5. They gave you the log of 2 and the log of 5. And they're asking you for the log of 10. Well, what's special about 10?
2 times.
It's 2 times 5. So we are finding the log of 2 times 5. Right? Now, how do you handle the logarithm of a product? You can pull that apart. How does the logarithm of a product get pulled apart? A plus sign, a plus, addition problem. So this will be the log of 2 plus the log of 5. Since 10 is 2 times 5, and the logarithm of 2 times 5 is the log of 2 plus the log of 5, we can just plug in our numbers. The log of 2 was 1.1, and the log of 5 was 2.2. So what's the answer to the question? 3.3. That was easy. Let's look at the next one. It looks harder. Now something there should be screaming at you. No radicals. So what are we going to do with that cube root symbol? Make it a 1/3, right? Fractional exponents are radicals. Radicals are fractional exponents. Now what can you do with an exponent? When you take the logarithm of something to a power, what can you do with it? You can bring it out in front. Now think about the given. You're sitting here with a 25. What's special about 25? It's 5 squared or 5 times 5, however you want to think about it. So now I'm going to rewrite that as the log base m. I prefer to think about it as 5 squared. Shoot, there's another exponent. What happens with that one? It comes out in front. What's going to be the total exponent out here then? I already have a 1/3. I'm bringing a 2 out. What's it going to be? 2/3. Don't we know what this is? So it's 2/3 times 2.2, which is 1.47, which I can get as a fraction if I want, 22/15. If I got that as a fraction. Or as a decimal, it's 1.4 repeating 6s.
Can you from the beginning just do log and 5 to the 2/3?
Absolutely you could. Absolutely. If you recognize that this is 5 to the 2/3, then you're going to jump straight from here to here. It's because you're an all-star. All right, one more. Log base m of 5m squared over 2. Okay, what's your thought about this one? Separate it. Absolutely. absolutely, it's a division problem. So how's it gonna separate? Subtraction. So it's gonna be the log of the top minus the log of the bottom. Now, I think this one's pretty much done, right? Maybe we can plug in for that one. This one, I think, got a little more work to do. Can that 2 come out in front? No, why not? Because it's only with the M. So, maybe we ought to split those? What's going on there? Multiplication, so we can actually split that into addition. So it would be the log of 5 plus the log of M squared minus the log of 2. Now tell me about this. This should just be popping out at you. What's this?
2.
That's just 2. That's 2. That's one of your properties. This is 2.2, and this is 1.1. So the answer to the problem is 3.1. Tonight, you'll get some practice with your word problems, using the formulas now that we've talked about them. You should be able to handle it. Tomorrow, we will start with our review work. I mean, we've kind of been reviewing as we've been going, but we'll start officially with the review work with the anticipation of a test either Monday or Tuesday. We'll see how things go.